Welcome to Uptime Spotlight, shining light on wind energy's brightest innovators. This is the progress powering tomorrow.
Today we're joined by Peter Winther, Key Account Manager at R&D Test Systems, a company that's revolutionizing how we test wind turbine components. R&D Test Systems is currently building the world's most powerful main-bearing test facility at the Lindø Offshore Renewable Center in Denmark. They have already delivered the largest HALT test bench for nacelle testing at the same location. And now these facilities are pushing the boundaries of what's possible in wind turbine testing with capabilities up to 25 megawatts. Peter brings extensive experience in large-scale test system development and has been instrumental in multiple groundbreaking projects at Lork. Peter, welcome to the show.
Thank you very much. Thank you for having me.
All right, so you're building a 25 megawatt main-bearing test facility. That's big.
That's very big.
So just give us a sense of scale. How big is a 25 megawatt bearing?
The bearing itself, I would guess the inside diameter is more than 4 meters in a typical bearing constellation. The test bench on the other side is also relatively big to be able to break that bearing or bearings, depending on what you're testing. The test bench itself, first of all, features a pretty decent size concrete block or foundation at the bottom, which is around about 35 meters long. It took 30 hours to cast the whole thing. It was a one continuous process. We had 280 trucks coming in, and they were coming in every 6 minutes. And so we basically took all, I think, concrete production from Fyn, which is the island where Odense or the test bench is being realized. And then we had back-off plants in case the plant went down, because, you know, if you start casting, you can't stop. You need to go ahead.
You can't have a cold joint. Yeah.
Yeah. So that's the foundation itself. An essential thing when you make a foundation like this is also to make sure it cools in the right manner. You can't just cast it, then go away and then come back in an hour or a week and then all is fine, because then you risk not having the right material properties throughout the foundation. So we had a more than 1 megawatt cooling system, making sure that the cross-sectional temperature throughout different cross-sections in the foundation was right and not too much of a difference, so we didn't get cracks and creeping and unwanted properties at the end, because you can't really get rid of it.
When you take this project on, how many engineering challenges are there? Obviously, building the concrete foundation by itself is a massive undertaking. How do you break this down, and how many big hurdles are there?
We're in the lucky position that it's not, you can say, the first time we're building a big test rig. It's the first time we're building one that should break a 25 megawatt wind turbine main bearing arrangement. So that's a first. We have some conceptual building blocks, which we of course relied upon, but it's the biggest we've ever made. So there's always challenges, and it's especially challenging when we need to break something very fast that is at the limit of what is possible to manufacture at this point in time. There's a reason why they're challenged with making 15 or 25 megawatt turbines or whatever they're saying they can manufacture now. It's because you need also the technology to make bearings sufficiently big enough, machining areas where you can machine the whole thing. And we need to break something that is intended for 20, 25 years of operation. We need to try to break that in 6 to 12 months. So it's a bit of an engineering undertaking to figure out, okay, how do we make our test bench capable of doing that 24/7 also for 20 years?
Well, I'm curious because you've already built a 25 megawatt HALT, highly accelerated life cycle testing, at the Lork, and that's there. So what was the need for a separate facility for the main bearing? What about main bearings makes the requirements a little bit different?
You can say in some areas the 25 megawatt HALT, it's used for validation testing. So that is actually for testing the entire drivetrain, meaning the DUT is a abbreviation we use, device under testing. In this case, it's the nacelle. And for the 25 megawatt Holt test bench we have already commissioned and is operation over there, it also tests the gearbox and the generator, which mean we need to be able to apply a pretty significant amount of torque also. You want to stress test the gearbox, ergo you want to have a lot of torque. For the main bearing test bench, that is not the case. You only have to overcome the friction in the bearings because they don't see the torque. The torque goes through the main shaft to the gearbox at the back end in case of a geared solution, and if not, then it's directly to the generator. But that's why the bearings are there. So it is actually overdoing it to test main bearings on the 25 megawatt Holt, because then you pay for a huge direct drive motor in this case, which you don't need in the test.
That makes total sense. Okay, so, and the issues that the industry is having with main bearings is pretty evident. And onshore right now, there's a lot of issues in the United States at the moment. But when we get offshore, that becomes even more critical as 25 megawatt turbines going to repair that gets increasingly difficult. So this is a really key piece of equipment for offshore wind. Isn't this probably the linchpin to success out on the ocean?
So at least very difficult to change if something goes wrong. Let's put it like everything is difficult to change offshore, but the main bearing arrangement, everything is attached to that in some way, more or less. It's the connection between the rotating part and the tower to some extent. So you need to take off a lot of stuff if you are to change the main bearing arrangement or the main bearings. So yeah, there's a lot of challenges there, and I guess what is evident and what they see is it is extremely important to test the bearings under the right conditions. So what they actually experience in the real life, to get as close to that as possible, which is also what has been sort of the focus on this test bench is the main bearing units. We don't test main bearings standalone, just a bearing, and then turn it around and try to bend it. Because it is very important, the housing around it, how the load is distributed in the bearings. What is it exposed to in the real life? You need to get as close to that as possible. So that has also been one of the focuses for this main bearing test benches. It's main bearing units, it's main bearing systems we need to test.
Is it actually easier for the main bearing to support the load while it's spinning, or when it's static, the actual hub?
Is when it's spinning, and I guess that's because if you have the large load when it's static, you risk that the oil is not properly distributed in the bearings and so on. So ideally, if you have the big loads, I'm pretty sure that the bearings would prefer to rotate.
So in this case, okay, now we're talking testing them. How do you? Okay, so when we talked to this a little bit off where you explained to us kind of like the test rig and what the hydraulic rams look like to put pressure on it in different ways. Do you do rotating testing and static testing with this thing for an accelerated lifetime test, or how does that work?
At the end of the day, it's of course up to the customer. They're the experts in how to test their bearings. So, but on the other hand, we are also trying not to limit them in what they can test. So it is also something we've been discussing with them, what their needs are in this area also, but ultimately, we also use bearings. So we have the same challenges and the same limitations. Some of our bearings, at least for the turbines that's going on right now, our bearings are still somewhat bigger, but we cannot, at least we also put in some constraints and say, okay, if you want to do static testing, then it might not be full load, or it might not be full load for several days or whatever. Again, we need to make sure that the large equipment doesn't break. But again, we also need to enable the customer to take their tests or their designs to the limit.
But that's an R&D specialty, right? That's what you guys do. You link up with whoever needs the test benches, whoever needs the testing mechanisms, and you say, like, okay, let's get your specific design criteria and what you guys want to do, and we're going to engineer this thing bespoke to you. But that throws in a bunch of other challenges for you guys as well, because now we're talking about testing 4-meter diameter main bearings, but you have a rotating rig yourself, so you have to have a bearing that's bigger and stronger than that.
Yes. That is always a challenge, and as you said, Joel, we start. It's also above my head here, the winning concept. So it's not like we come with a given product or a given solution that fits all testing needs. We usually start together with a customer with a blank piece of paper, and then figure out, okay, you have a given test need or an idea at least, and then we figure out it along the way, and then we find the winning concept. And when we start with different concepts, of course, we have a track record, and we have proved different concepts, that use different concepts, and there's some of them we've used several times because they're suitable for scaling up. And then we mature that along with the customer and make it sure it's capable of fulfilling the customer's requirements. But it is a challenge that we need to break the largest bearings that are being manufactured while still using bearings in our rig.
Where do you draw the line at, Peter? They come in and say, I need a 25 megawatt bearing test center. And you say,
It's at the end of the day, it's the customer's wallet that draws the line.
Good reason.
We could make it bigger if needed, but again, it's also how big are they gonna get, and how much do we need to future-proof, and so we usually don't draw a line. We always try to find solutions. Same with the 25 megawatt Holt test bench we talked about previously. At that point in time, we couldn't get our hands on a direct drive motor of that size. So we had to design and engineer and manufacture it ourselves because that was the need for the given test bench. So we don't say like, okay, you want to go above 25, keep us out of it. It is usually also a financial decision. We also had bigger on the table, but bigger is more expensive. So it's always, it also refers back to the investment and the business case. And
how much of a 25 megawatt main bearing test rig is designed by R&D Test Systems that is unique to that test bench?
95, 99% as the control system is based on common industry, you could say, control, hardware, software stuff. The foundation, one of a kind. The main shaft, one of a kind. The bearings are actually also order of one of a kind. The housing is, of course, also one of a kind. The hydraulic cylinders, they're made to spec, so it's not something we're taking from a serial production. It's made to us, and it's made to what we need for this one. Some of the biggest hydraulic actuators in the bench, each of them apply more than 1,000 ton.
Wow. So that requires a team of engineers. What does that staff look like?
The project team at peak was, we are in manufacturing phase. We are having things manufactured and also soon delivered at site. So we are on the other side of the peak where all the engineering was carried out, but I guess 30, 40 engineers working on them.
That seems like not enough.
It is actually.
Yeah, so because you've done it before, you have it honed, and so there are multiple phases to this. And as a project person, how does that work? Like the customer picks up the phone, calls you, and says, "I need a 25 megawatt main bearing test facility," and someone takes that phone call. What happens from there?
Usually they're not that specific, but they send out a request at least. We have some testing needs. We can start with, let's say we start with a feasibility study, figure out together with the customer what do they need, what sort of concept is the winning concept, and so on. If they call, depending on which number they call, and so on, but they would probably start with me as I'm a sales representative, key account manager. So I would be in that process as well, and then taking it all the way to telling the customer what the thing actually costs. You can say part of that journey is also, there is always, at the beginning, everything is need to have. But when you put a price tag on what the different requirements cost, some of them become nice to have. That's also some of the journey we have with them together. For this one, for example, there was one particular load case which had some pretty aggressive dynamics. And dynamics, when we have hydraulics, we need a pretty big HPU. So that one load case implied the HPU had to be tripled compared to all the other load cases. So all of a sudden, that given requirement became a nice to have because they could just spend 3 times as long. That was okay with them. So lowering the frequency. And then at some point, then we get to the point where, okay, they have the requirements, we have the solution, and they're satisfied with the solution. In this case, it was sort of a joint 3-party venture because we are the test bench realizer. Our customer is Log, which is a commercial test center, and their customer on the other side, that's Schaeffler from Germany. So it was, you can say, a bit odd because the requirements were actually coming from Schaeffler through Log, but to us, but we were all working together on it to find, okay, now this design fulfills the requirements, and this is then the cost of it. Are we go ahead? And we were. And then internally in R&D, we handed over to operations, that's what we call it, which realizes it. So they take it from purchase order and then all the way to hand over to the customer.
So there's 2 questions there. How long did it take to iron out the specifications with everybody at the table? How many months was that? And then once you decide to build it, how long does it take to actually to complete a project?
So from, you can say we start to, it's going to be completed, building is around about 24 months. The process leading up to that, so the sales process was also, I would say, delayed. It was quite long, and it was influenced by probably some geopolitical situation going on in some part of Europe where, something happened at some point, which changed priorities at the customer. So it took actually years, I would say, because one thing is settling on the requirements, another thing is also like it's a big investment. So committing to that takes some time.
Is it quicker to build than it is to specify then?
Not at all. Once we got, there was a big pause. So that shouldn't be part of that time. So once we got into the specification phase, it was I would say pretty intense months, but really good cooperation between the 3 of us.
And R&D is going to open the facility in 2025.
2025, yes.
So how soon before it then becomes commissioned and ready to take that first main bearing? Is it ready to go sort of day 1 there?
That's the intention, yes, or the expectation. So right now, process-wise, we've left site, we've made the foundation, and now we've stepped back a little bit, and now the building is being erected around it. It's easier to make the big concrete block first and then build the building around it. So they're making the floor as we speak. They might have finished that already, and then they'll build the walls around it. And then come start next year, it's the intention we'll come back in and start installing auxiliaries and the test load unit, and then we'll be ready.
You know you're making a big piece of kit when the building has to be built around it.
So obviously R&D Test Systems is the leader in big test equipment and building these test benches. There's, you do impressive work. How much is on your plate at the minute? You have this 25 megawatt facility going in. Are there other things already in the pipeline that you haven't even announced yet that you're working on? How busy are you right now?
So we're busy realizing the projects we have, unfortunately, I'm not allowed to tell too much about the pipeline, but we definitely have some interesting stuff going on. That's for sure.
Well, that's the beauty of R&D Test Systems. If you need somebody to build a piece of test equipment for big machines and do it right, I would imagine there's only one place to go, and that's R&D Test Systems, and you're going to have to get a hold of Peter because Peter is their salesperson.
Give me a call. I'm not the only one, but I can promise our sales organization, our sales team will take good care of you if you have that particular need. We'll love to help you solve it.
How do they reach you? How do they contact you?
We have our webpage on rdas.dk where there's contact information where they can reach us.
Yeah, and Peter's available on LinkedIn. So if you get desperate and you need you need to have a 25 megawatt main bearing test facility built in your backyard or 30, you just reach out to Peter. He's ready to take your phone call. And I every time R&D Test Systems comes on the podcast, I'm always impressed because you're doing such amazing things, and it's such a benefit to the industry. And congratulations on that. Come on, I know how hard that is to do, and I know how successful these test benches have been. That's truly amazing. So, Peter, thank you for being on the podcast. It's been wonderful to have you.
We're just a small piece of the puzzle, and we're just helping, trying to help this green transition, and having wind succeed because it's awesome.